Well, hello everybody. Welcome into Great Atmosphere here on Monday, February 19th of 2024. Want to do a quick apology on not having a video out. Last Friday had some real life things come up. Wife was sick, had some work stuff I had to take care of. Just didn't work out for that particular day. But we are back here on this Monday afternoon. First, want to take a look at some pretty interesting stuff that's been going on here across not only our neck of the woods, but also the world. What we're looking at right now is the southern portions of the South American continent, and you can see there is an anticyclonic motion because it's in the southern hemisphere, tropical cyclone of some regard that has formed off of the Argentinian coastline, off near Uruguay and the southern coast of Brazil as well. South American tropical systems are inherently rare in that of themselves, and they're quite interesting to look at as well, just because they don't get a lot of inherent, not a lot of tropical moisture to contend with in the first place. So the fact that they have enough to spin and develop a warm core is quite significant in that of itself. But you can see from this map of global tropical cyclone tracks and where they typically occur, you see the majority of them obviously are in the tropical Atlantic, the tropical Eastern and Western Pacific, and the majority of the southern tier in the Indian Ocean and the Indonesian and Oceanic archipelagos. But then you see the areas in between Africa and South America are completely sparse, and that's generally because this is cold. There's a lot of cold water gets advected up and in here and gets trapped. The majority of the tropics kind of come and meet, assuming that the right up in here is where that initial Antarctic current comes up, and it meets that tropical moisture and just kind of fizzles out anything. So anything tropical in nature that does form on the southern tier of the Atlantic would have to form kind of in this pocket right here, because this is the area where the water would have enough time to modify and get warmer in general by being in those farther northern latitudes, closer to the equator. So that's ultimately the only opportunity that you would ever see a tropical cyclone form in the South American continent would be right around this region, and there's only been one that actually met tropical cyclone strength, where it would be categorized as technically a hurricane, and I believe that was actually relatively recently, if I remember correctly, it was back in 2019. And now we have this one. This one is already starting to dip a little bit too far south, and it will lose any of its tropical characteristics and definitely start to become subtropical. But certainly a very interesting phenomenon going on in South America, and who knows, could be indicative of some things to come. And another cool thing about the tropical area right here is like I get a lot of questions about, hey, well, I mean, it's near the warmest spots of the globe, so why is there no cyclones around the Indonesian archipelago and the northern portions of South America? And that's simply because that's next to the equator, and there is no Coriolis effect. Coriolis has to do with the Earth's rotation, and the further away that you are from the equator is ultimately you have a more enhanced Coriolis effect. So the areas where there has a slight amount of Coriolis, along with warm, moist tropical air and limited wind shear, which would be the tropics, so around the Tropic of Cancer and the Tropic of Capricorn. Those are the regions where you would see tropical cyclone development. Unfortunately for the South Atlantic, or fortunately for the South Atlantic, does not have access to the necessary warm, moist waters that would develop the convection necessary for a warm core system to begin. So just fun little thing. We're going to take a look at what we're going back to the States. We can take a look at our last 72 hours of snowfall analysis. We had our series of clipper storms that succeeded our major nor'easter that occurred around Tuesday of last week, that affected the greater parts of the Midwest, Great Lakes regions, and the Northeast. Specifically, it seems to be a pretty significant Lake Ontario lake effect region across the upstate of New York. And then we also had a really interesting convective snow band that formed in the east central PA into central New Jersey and actually affected the lower regions of Manhattan, along with the Allegheny Mountains on the western facing slopes. Those areas received quite a bit of snowfall, and then also we had some increase of the snowpack across the Sierra Nevada, the Cascades, and into the Intermountain West. You can actually see the results of some of that snow start to make its way across the Midwest on the ground. Generally speaking, all these areas that you see with white that are static on the ground are definitely snowpack related. And then we also have our major system that was affecting the majority of the Florida Peninsula and across the deep southeast across the weekend. I had our big El Nino subtropical jet just cranking. It was a major atmospheric river, and I don't know why more people didn't call it that, because that's what, by definition, it was. It was an atmospheric river event that effectively was the same one that affected California. It just kind of got interrupted by the high topography of the Rocky Mountains down into Mexico, and then once it made its way back over to the Gulf of the Caribbean Sea, started cranking again and developed a lot of that moisture, and kind of put a damper on anything that the entire weekend for the majority of Florida. I know the Daytona 500 got postponed along with all the succeeding races around in the NASCAR world. It happens. That's just one of those deals, but this is certainly something that is more El Nino oriented. And as that main low that is forming on the in the left exit region of that giant upper level trough, we would expect that to start moving off of the Atlantic coast. And as you can see, that sunlight has started to make its way across pretty much the majority of the southeast as we move forward into today. And then the other big story that's coming in is California going to endure yet another atmospheric river event. Not as severe in terms of precipitation, but this time there's actually a legitimate severe weather threat affecting not even the Southern California regions around the LA Orange County region, but actually in the Central Valley, more closer to Sacramento, which is quite interesting. That area very rarely gets any kind of severe weather in a supercellular sense, and today it looks like later on we could be seeing that for the California region. We want to take a look at some of other little isms that are going around in the North American subcontinent. We see big upper level lows off the southern coast of Greenland, and obviously the main one that's off the Cascadian Plateau and the central north central Pacific Ocean. You can see those are screaming. Actually, these are pretty significant wind gusts. I believe that's over 100 kilometers an hour. That's quite significant for a surface low, and those winds are also whipping off of the Oregonian coast as well. And those are generally due to the upper level pattern. And we see, wow, these are massive numbers. I can't necessarily see it because of my recording software, but this is setting records for upper level wind strength. That jet streak is a combination of both the subtropical and the polar jet. The polar jet streak has formed over the Canadian Prairie and the Hudson Bay, and is converging with the subtropical jet that has been dipping over the Gulf of Mexico and up the Gulf Stream. Those two interact, and in the lee of those forms the surface level low that we see over Greenland. And conversely, the same kind of dip and trough setup is being formed as the jet streak goes over Southern California up and into left exit region of that particular streak. We get that low center formed off of Oregon. We also take a look at the Pacific Coast water vapor imagery. We can see the upper level flow, generally speaking, diverging, creating a lot of that diffluence aloft, which is going to create the necessary convergence at the surface to develop convection, and ultimately upper level divergence aloft that will help to spread out that convection through the entire deep layer of the atmosphere. And you can see that low generally forming right in that corridor right there. We have big time moisture making its way up and into Idaho and the Cascadian Plateau and the Washington and Oregonian plains. And then and we see little pockets of convection starting to pop up here going into Northern California and the Central Valley regions. That will be our main player going into this afternoon. These little pockets will start to rotate, and we'll see ultimately what comes out of that. And we can see another look what that looks like in terms of the diffluent air. We see generally that jet streak starts to go in this. Let me change the color here. So we have flow that is diverging in this particular region right here, and then we have our high over low pattern across the we have we have our high, and then we have a low. That's a typical Rex block pattern that typically works to separate out, in addition to the topographical elements of the Rocky Mountains, working to create that diffluence. And in that lee, we have a low pressure system forming here, which will ultimately work to create a big problem for the Central Valley. We can take a look at what that water vapor transport looks like from an integrated water vapor analysis. We can see that, generally speaking, this is working to produce a lot of increased humidity and a lot of increased dew points across the California region. Will ultimately be the genesis for these storm systems. Now we take a look at what the convective outlook looks like. We can see it's an all hazards outlook, but primarily I'm kind of more concerned about the tornado risk here, a 5% risk across the Central Valley areas around. These areas they don't get tornadoes. They just don't. Very, very rare. Not a lot of people know what to do when they're under a tornado watch. I do probably expect this area to be under that tornado watch advisory going into the later portions of today and into the afternoon hours. So a 5% risk is actually quite high, I think, for tornado probability. And there's a lot of different factors that go into why this might be. We're taking a look at the SBC mesoscale analysis. This is looking at a beta particular parameter called tornadic tilting and stretching. It's primarily a good, I've used it before to kind of denote low cape, like skinny cape scenarios that may make its way kind of more colder season type of tornadic setups. And the thing, generally speaking, that you need for any kind of supercellular activity is you need enhanced wind shear. And if you don't know what wind shear is, it's the difference between both directional and wind speeds with height. So if it's like really, really low wind speeds coming out of the southeast, and then you go like a kilometer up in the atmosphere, and there's crazy 60-mile-an-hour winds that are coming out of the west. That would be significant wind shear, because you would see that the winds start out like this, if this is like a profile of the atmosphere, and then they'll eventually do something like this, right? So if they're doing this with height, kind of like that, as you go up, then you know that there is enhanced wind shear, and that creates a spin environment within the atmosphere where any kind of rising motion that occurs will be in a kind of a spin cycle in that sense. And also, but in order for that to happen at all, you need rising motion inherently, and whenever we have rising motion, it usually comes with the interactions of excuse me, I gotta get this out of the way. There you go. It usually here we go. And yeah, it usually comes with a mixture of cold air aloft, and then we have warm air being advected in at the surface. So in this particular scenario, we have warm air that is being advected right here, right? But if you don't know, there's a lot of mountains here, right? And those mountains are actually going to work to push this air that would otherwise be coming out of the southwest and make it go in this direction instead, right? So now the air that is up here that is decidedly more cold, and remember, this is warm, right? So the decidedly colder air that is up here in the north that is going to be coming around that major low that we talked about earlier will start to be coming in this general direction aloft. Cold air sinks, warm air rises, and we have significant shear along these lines as well. In terms of directional wind shear, that is a major component for creating enough spin and convection necessary for that to happen. Now, the main thing that at least I'm looking at is whether or not we're going to have effective enough moisture involved here, because not only do we have to have wind shear involved, we have differences in wind shear, we have to have differences in temperature, we also have to have differences in moisture in order to create a genuinely full-fledged supercellular environment. And I'm just going to take a look at a few things. I haven't actually looked at these so far yet, but I'll take a look at precipitable water. That's a good indicator. So we have, generally speaking, we have this main element of the river starting to make its way up and in. Anytime we get over 1, I would say that's a good enough parameter to be able to denote whether or not we have good enough moisture in order to create a significant amount of of lift and necessary different, mean difference in the atmosphere to create that supercellular environment. So if we can get a little bit more of a, let's look at dew points. Can we see dew point? Just dew point. 3-hour dew point change. Okay, so I mean, that is still going to be that's the major if scenario here. I think is whether or not we get enough. Okay, we got enough moisture convergence to begin a little bit of precip. If we can get dew points to start to go a little bit higher, we got dew points here. Okay, so dew points in the mid 50s, 56. I think if we get up to 58, 59 dew points, that would be the danger zone, I would say. So, and remember, I'm filming this at 2:30 Eastern time. It's only 11:30, obviously, on the West Coast. So, and this will be a late afternoon system for them. So definitely more than enough time for enough moisture to kind of be advected and moved in it from a southeastern point of view across those mountains that we talked about at the surface. And it'll just be one of those things. And I hope everyone ultimately stays safe in this region because, as I said before, not a particular I don't want to say well educated, but certainly not very experienced area for people to be dealing with severe weather across the Central Valley of Northern California. I want to take a look now at some things that we might be expecting here in the future. We can take a look at our Euro anomaly. We talked about last week about the possible resurgence of the polar jet as we move forward in time, and we can see that ultimately outlined still in the models. We have a area of low pressure in the upper low, and then we have a convergence with ridging right below it, right here, and this is certainly a signature polar jet scenario. We have our main low that's going to be creating enough problems for California to the West Coast coming up. This is out Friday of this week. So as we move forward, we can see an interesting setup that we have going forward. We have a polar jet, right, that is going to be working to ultimately advect in, generally speaking, colder air aloft. And whenever that occurs and we have a ridge that sits over the southeast or the Gulf and in that general region, we have general troughing that goes over ridging. And this is a very active spring-like pattern, just because when you have interactions of cold and dry air interacting with warm and moist air that's sitting over the southeast, and of course we're in a transitional month coming up in March, this would be, I would say, as an indicator that we could be getting some severe weather in particularly the Mississippi River Valley and into the southeast, depending on where this high ultimately likes to settle, because anything that dips down from this polar jet will have definitely the cold and dry characteristics in order to create. And also a very important element is we get southwesterly flow coming out of the deep southwest and over and into the mid-Atlantic. That is a pattern that typically is conducive for severe weather. Hopefully not you never want to root for severe weather, particularly in the plains in the southeast during March and April, because obviously that is the kind of the heat of tornado season. It's not a particularly promising look if this continues to be the trend. Unfortunately, it has been the trend here for about a week, and I would expect to start to see it in the global models. And we've already actually seen a little bit of this as well. We can take a look at the total QPF and what the Euro is predicting over the course of the next week or so. We can see that begins Thursday, Friday. We get a little bit of a system that occurs over the mid-Atlantic. And then we have our next big system start to make its way over in the Pacific Northwest, ultimately starting to fill in this particular region of the BC, Northern Idaho, Washington, Cascadian Plateau, and the Intermountain West, which will begin there. We can take a look at what that looks like across the global models as of right now, and just to kind of, generally speaking, take a look at what the weather is predicted to look at over the next few days. We see that atmospheric river event and severe weather outbreak across California and into the Pacific Northwest. That energy will start to make its way across the Rockies, and generally we'll create, we'll have ridging across the majority of the states going into the early parts of this week, as the energy starts to create that's lee side low that we know and love, as has been our major contributor for weather here, or just unsettled weather across the eastern seaboard. We see that low start to form. We see the high form here, and then we start to open up the moisture, and we'll get something Thursday, Friday, Saturday. Not a lot of confidence that it will develop a big moisture plume out of this. Both models are saying there will be something. It does not seem to be a lot of agreement on what kind of convective mode that is going to be. Europe has much more of a widespread rain shield. GFS has more of a QLCS squall kind of look to it. You can see the warm air actually makes its way all the way up and into New England, so it's not as much of a snow threat up, or I shouldn't say New England, I should say the Northeast, because you can see the upstate is generally rain according to the GFS, and it's fully rain according to the Euro. GFS is a little bit colder on the northern parts in New England, so it could be in the upper elevations, specifically around the Hudson, Connecticut River and Mount Washington regions of New Hampshire and Vermont and Maine. They could be seeing some snow according to the GFS, but the Euro keeps everything generally just wet with rain. And then we move into the weekend, and there's a little bit of a lake effect thing going on as northwest flow comes off the lakes. Lakes are still relatively ice-free, still very anomalously ice-free, very concerning for that particular region, I think, in terms of snowpack levels. And then, but thankfully, there hasn't been a lot of forcing to create such a devastating lake effect season as it probably could have been. We can see our next system forming off the California coast as that low starts to dip down, and then we get into next week, where we have that system start to move down and into the plains, and this is where the severe threat starts to be of a little bit of a concern for me. We have ridging in place, major trough. You can see that the cold air has made its way all the way down into the Four Corners region, and then we have our high that sits off the Gulf Stream, opens up right here, bringing in the warm and moist air, and that converges with the cold dry air that's being forced in from the Canadian prairie, which will maybe create more of a severe threat than we are wanting. And we can see this semi-reflected in the CPC precipitation outlook here. We can see this has generally gone more moist with their February 18th outlook that was released yesterday. And then, interestingly enough, another thing to take a note at is the temperatures. Above average temperatures, the polar jet that we talked about is not going to, it doesn't have a lot of forcing to keep the majority of the cold air over the whole of the North American continent. And the main reason why that is that we do have our polar vortex, which is fully displaced, and we've been talking about this ad nauseum about what the disruption of the polar vortex could mean. What is currently happening is we have our major upper level high that is sitting over Alaska, and then we have the main low, which is the actual polar vortex right here. But you can see that the actual polar vortex is sitting over the Russian subcontinent in Siberia and the Scandinavian plateau over in the Eurasian continent. So this is where you can, and I can probably just better say, this is anomalously cold. Apologies for that. And then this is anomalously warm air that we are seeing ultimately over Alaska. And what this is ultimately doing is this is just the only area in the world where we're seeing Arctic temperatures. Everywhere else is just a transportation vector of warm air that goes around it. And you can see in this particular setup that the warm air, if it comes and it is affecting around the polar vortex, that is being transported down and into Europe, and it is being down and into North America before it reaches this blocking setup over the Icelandic Channel and the United Kingdom. So what does that look like on a map? It just kind of looks like this. So we see The majority of this is essentially the North Pole, sitting over Kazakhstan, central Russia, Mongolia, that general region, and then everywhere else we see anomalously warm temperatures, primarily in the same. We're looking at mainly the same latitudes to be able to see different correlations here. So a lot of anomalously warm weather over, particularly Eastern Europe and Europe as a whole, and then the central plains and pretty much North America as a whole. Just based off of that polar vortex displacement. Now, I mean, it's I don't want to say it was random by any means, but I mean, like, it very well could have been over the North American continent, the polar vortex itself. It's cold air is much more easily managed, I'll say, over the Eurasian subcontinent, just because it is a larger landmass, and land definitely holds cold air better than any maritime landmass does, which definitely due to how the North American continent kind of works with the additions of the Hudson Bay and the Greenland channels and the Aleutian areas and the Bering Sea. There's a lot more at play there in terms of air mass modification. So it makes sense that it currently is sitting over there. And in terms of moving it, we've talked about the MJO. I don't have an MJO slide here available for you, but the MJO is specifically going neutral. So any of the tropical teleconnections that would be working to kind of move that polar vortex in and around and kind of circulate it around the Arctic Circle, it's largely just non-existent. So a lot of the forces that are necessary to move the polar vortex and make it kind of go in like a spiral pattern, so it would go this way and then the warm air would shift this way. It just does not exist right now. So ultimately, it kind of just looks like this. This is the temperature anomaly for the next 10 days. This is what the models are expecting. And we can take a look at what that means in terms of us here in the North American continent. We see generally mild conditions over the plains and into the Four Corners region, and generally cooler across the southeast and the Eastern Seaboard. And this is an anomaly map, so obviously these pay attention to like the numbers in your neck of the woods of what makes more sense to you. But so like obviously I'm here in the Charlotte region, so 56 is still pretty cool climatologically for us. But it's generally like upper 50s, early or lower 60s this time of year. But if you were to go into like northwest Iowa, if you told them at mid-February that it would be 45 degrees, they'd be like, "Oh my gosh, we're going to be sweating outside." So they just take a look at from that perspective. We'll go forward day by day. Moving into Tuesday, you can see 60s, 70s, 60s up into the 70s, 80, 85 along central Texas, 85 in mid-February in Texas. That's something else, and then it might get a little bit hotter here. Getting close to, we're touching the 70s in Kansas and central Missouri on Wednesday. Still generally cool in the east and the west going into the middle parts of the week. And then we finally get a little bit more mild in the eastern portions of the country going into the final parts of the week, before we all just kind of level out with mild temperatures with a little bit of that clipper that comes through in the northeast that we talked about according to both of the global models later on in the week on Friday and Saturday. And then and that's generally, I'd say the major risk here is, this is the day 5 to 10 temperature anomaly for the whole of the continent. We have a tale of two scenarios here. So we have our warm air that's sitting under the high that's advecting in that warm and moist Gulf air, and then we'll have our polar jet, which is formed and will ultimately start to go kind of in this direction, creating southwest flow and a convergent zone over our general Mississippi, Tennessee, Ohio River Valley regions and into the southeast, depending on that placement of the high. And then depending on, I don't know if this will ultimately work to shut off the valve in terms of the atmospheric rivers, because those will still work to form off of the coast here in the lee of the upper level system that is still working its way across over and across. We are in a I don't have this ultimately fully seen, but I want to do that real quick to be able to see where that North Pacific jet currently is sitting and whether or not it's in a retraction or not. So we have the extension that's making its way through here. We can move this out And yeah, we still see a jet retraction for the North Pacific jet, but we also see that major separation between the two of the jets. So we have our polar here, we have our subtropical here, and they work to form and merge there. And this merging right here will make its way up and into the whole of the contiguous U.S. Moving into the beginning of March. So that's generally kind of the risk, I would say. We have severe weather potentially on the horizon. Doesn't seem to be a lot in terms of risk for another cold blast. Not right now. Not saying it's like officially the end of the potential for winter or anything in the southeast, but those chances as the days go on look bleaker and bleaker, especially as we sit under this mild air for a long enough period of time. The soil starts to heat up. Anything that ultimately would stick inevitably would have a very hard time staying frozen since we are under such warm conditions for such an extended period of time. So my outlook on that continues to kind of shrink, but the increase in likelihood for an active severe pattern across the eastern parts of the U.S. is certainly elevated according to the analysis today. So that's all I got for you today. Once again, my name is Zach for Great Atmosphere. I appreciate you tuning in. I'll be doing forecast videos like this every Monday, Wednesday, and Friday, and I would appreciate your subscription if you are so inclined and interested. And other than that, I will see everyone here on Wednesday for another forecasting video. Take care.